It began with a whisper from a different time, a whisper born not of flesh or voice, but of circuitry and silence, a message carried on metal wings across billions of kilometers of emptiness. In the late 1970s, while the world below was still learning to understand digital clocks and cassette tapes, two machines were lifted into the sky with a mission that seemed, even then, impossibly ambitious. Their names were Voyager 1 and Voyager 2. And what they became, what they still are, defies reason. The original mission sounded modest on paper. Visit the giant planets of the solar system, snap some pictures, collect some data, and beam it all back to Earth. That was it. A scientific road trip. Yet what unfolded was nothing less than a journey into myth. Voyager didn't just explore, it endured, it transcended, it lived. And here's the impossible part. It's still alive. 48 years later, in 2025, long after the labs that birthed it have fallen silent and the engineers who assembled it have grown old or passed on, Voyager is still sending signals across the abyss. These two spacecraft, each no larger than a small car and powered by technology less sophisticated than a modern calculator, continue to whisper through space. And that whisper is no faint echo. It is a heartbeat, steady, deliberate, and impossibly strong. But how is this even possible? To understand the miracle of the Voyagers, we must return to the beginning. Back to a time when Earth was different. The world was watching on grainy TVs. Computers were rare and huge, and the very idea of touching the stars felt like a dream clutched too tightly. Yet amid that age of analog and aspiration, something extraordinary was conceived. The Voyager spacecraft were crafted with meticulous care and designed to outlast every doubt. They were engineered with the kind of stubborn brilliance that defined an era. Code written by hand, circuits soldered by visionaries, and every bolt chosen with reverence. Once launched, the Voyagers began their long journey through the solar system, passing the giant planets one by one. Jupiter, with its endless storms. Saturn, crowned with icy rings. Uranus and Neptune, cloaked in mystery. Each encounter was a ballet of timing and physics, the spacecraft flying past with just enough distance to survive, but close enough to capture what had never been seen before. What they saw changed everything. Yet even that was only the beginning. After their planetary dance was complete, the Voyagers didn't stop. They didn't slow down. And they certainly didn't fade away. Instead, they kept going, pushing beyond the last glimmers of sunlight, deeper into the cold void where nothing human had ever reached. Today, they are farther from Earth than any other human-made object has ever traveled. Voyager 1, more than 24 billion kilometers away. Voyager 2, close behind. But deep space isn't like we imagine. It's not a minefield of asteroids or glowing clouds. It's empty, unimaginably empty. Even when the Voyagers crossed through the asteroid belt in their early years, there were no impacts, no close calls, just silence. The belt was nothing more than a ghostly veil, its rocks so scattered that you could fly for days without seeing a single one. This emptiness became their sanctuary. Even when they passed through Saturn's rings, a region dense with dust and danger, they survived. Voyager 2 was briefly pelted by microscopic grains, too tiny to see but real enough to register. The spacecraft trembled for a moment. Its thrusters fired, its antenna realigned. And it pressed on, unharmed. Still, the greatest threat was never dust or distance. It was time. Time, that tireless destroyer of machines. Time that wears down metals, erases data, and frays wires thinner than hair. And yet, the Voyagers endure. They function not because of luck, but because they were built to persist in a way we rarely build anymore. They are monuments to human determination, our willingness to create not just for success, but for the future, even a future we may never see. By the time they crossed into interstellar space, leaving behind the protective bubble of the sun's solar wind, the heliosphere, they entered a realm even more silent than before. Here, the density of matter drops to almost nothing, fewer than 1 atom per cubic centimeter, a true void. And in that emptiness, they glide like ghost ships in a frozen ocean, untouched, undisturbed. But how do they keep moving? How do they not slow down? That's the beauty of space. Once something moves, it keeps moving, forever. With no air, no friction, nothing to resist them, the Voyagers need no fuel to continue. Their only push came at the beginning, first from Earth's rockets, and then from a genius bit of orbital magic: gravity assists. It's one of the most elegant tricks in spaceflight. Use the gravity of a massive planet to swing a spacecraft faster, stealing a fraction of its momentum in the process, like a cosmic slingshot. Voyager 1 and 2 used this technique with stunning precision, catching rides from Jupiter, Saturn, Uranus, and Neptune. These maneuvers didn't just save fuel, they unlocked the impossible. All of it was only possible because of a rare planetary alignment, an event that happens just once every 176 years. The so-called Grand Tour allowed NASA to send the probes on a path past all four gas giants, hopping from one to the next with gravity as their guide. The timing had to be perfect. And it was. To grasp how Voyager still survives, we need to peer into its heart. Not a beating one, but a glowing one. A heart forged not of blood and tissue, but of plutonium. Specifically, a radioactive isotope called plutonium-238. When the Voyagers were designed, NASA knew that solar panels wouldn't cut it. Not for this journey. The sun's light fades with distance, and beyond the orbit of Jupiter, it becomes too dim to power even the simplest systems. So instead, they gave the Voyagers nuclear hearts, 3 radioisotope thermoelectric generators, or RTGs, per probe. These aren't reactors. They don't explode or spin turbines. They simply radiate heat as the plutonium decays, and thermocouples convert that heat into electricity. No moving parts, nothing to break. Just steady, patient warmth that became power. It was a choice that required faith. Not just in physics, but in time. But time, as always, is not kind. That heat, that electricity, is fading. In 1977, each Voyager had nearly 500 watts to work with. By 2025, it's closer to 200. Barely enough to power a couple of household light bulbs. And yet, they endure. Not by doing more, but by doing less. Over the decades, engineers have made painful choices. One by one, they shut down systems. Heaters were turned off, even when it meant letting some instruments freeze. Scientific instruments were powered down, not because they broke, but because they were luxuries the spacecraft could no longer afford. And so, Voyager entered a kind of quiet hibernation. A graceful aging, not unlike that of a wise elder. Fewer words, but deeper ones. Only the essential instruments remain. The spacecraft no longer sees. Its cameras were turned off long ago. It no longer spins or scans, but it listens. It listens to the music of the void. Each Voyager now operates with just 3 main instruments: the magnetometer, the low-energy charged particle detector, and the plasma wave sensor. They don't paint images. They sense vibrations, fields, and particles. They're ears, not eyes, perfect for deep space, where light is rare, but music still exists. There were close calls, moments when the mission could have ended with a whisper. In 1978, Voyager 2 lost its primary radio receiver. Most spacecraft would have been lost then and there, but Voyager had a backup. It clicked on, and has been in use ever since. Then, in 1981, a mechanical failure jammed the scan platform. That should have crippled its ability to observe. But the team, working from over 1 billion kilometers away, sent a sequence of commands so precise it unlocked the mechanism, as though reaching through the void with invisible hands. But time doesn't stop testing. In 2022, something even more mysterious happened. Voyager 1 began sending back garbled data. It wasn't static. It was nonsense. Telemetry about its orientation became unreadable. Engineers were baffled. Was it a sensor failure? Radiation damage? Something worse? They hunted through logs, simulations, and decades-old schematics. And then they found it. The spacecraft's computer was writing data to the wrong memory location. A glitch, yes, but one with the power to blind the probe forever. The solution was delicate. They couldn't rewrite code like they would on a modern device. The system was ancient, fragile. Instead, they found a workaround, a way to bypass the bad memory, redirect the data, and coax the signal back to life. And then, in 2025, silence. Voyager 1 stopped speaking entirely. No telemetry, no heartbeat. Just a cold, cosmic hush. Engineers feared the worst. Was this the end? After nearly 5 decades, had the universe finally claimed its traveler? But again, against the odds, they pulled it back. They rerouted commands, accessed a backup system, and found a way to restore contact. The spacecraft responded. It was alive. And what kept it alive, through all of this, was not just hardware. It was people. The engineers who refused to give up. The scientists who pored over old manuals like archaeologists reading stone tablets. The silent prayers sent to an aging machine drifting billions of kilometers away. This isn't just a story about a spacecraft, it's a story about love. The quiet, relentless love of human minds for something they built, something that became more than wires and circuits. It became part of us. And still, people wonder, why can't we just turn the cameras back on? Why not capture one last picture of the void? But it's too late. The cameras were permanently shut down. Not paused, disconnected. Their wiring severed, their memory reallocated. Even if they were intact, there would be nothing left to see. Out here, light is a rare visitor. The stars fade. The emptiness is so absolute, even the brightest galaxies are just faint whispers against the dark. And the old analog sensors, built in the 70s, would never survive the cold. They needed heaters to operate. Heaters we can't power anymore. So the last image Voyager captured was its goodbye. A single frame, taken at Carl Sagan's request in 1990. Voyager 1 turned its camera homeward, looking back across 6 billion kilometers. There, in a shaft of sunlight, was Earth, less than a pixel wide, a pale blue dot. In that image, every war, every poem, every love story, every child, every prayer, all of it sat on that pixel, floating in darkness. It was the final photograph. And maybe it was better that way. A final glimpse, not into the void, but into ourselves. Today, the Voyagers drift through a place no one has seen. A place where space is not a backdrop, but a presence. A silence so vast it almost feels alive. They are not orbiting anything. They carry a message. Not one of instructions or commands, but of existence. Of who we were. And perhaps, still are. Each Voyager was launched with a golden record. A time capsule etched in metal meant not for us but for someone, or something, out there. A greeting card from Earth, riding alone through the stars. Embedded within those disks is a map of our solar system, sounds of our planet. Waves crashing, birds singing, a baby crying. There are greetings in dozens of languages, mathematical truths, and music from across cultures. Bach and Beethoven, Chuck Berry, and a recording of a mother's heartbeat. This record was never meant to be found. The odds are staggeringly low, the distances too vast. Space is not crowded. It's empty beyond imagination. The golden discs are more than messages. They're a statement, a gesture, a human act of hope. A way to say, we were here, we mattered, and we reached. And maybe that's the point. Even if no one ever finds them, even if they drift through the void for a billion years with no witness, the fact that we sent them is enough. In an age of conflict, of uncertainty, of digital noise and short attention spans, the idea that we once built something simply to explore, to wonder, to connect, that is worth remembering. That is worth honoring. As of now, Voyager 1 is more than 24 billion kilometers from home. Voyager 2 slightly less. Each is moving at over 17 kilometers per second, fast enough to cross the distance between Earth and the Sun in just a few months. They've escaped the pull of the Sun. They are beyond the reach of any orbit. They are on eternal trajectories, never to return. But the road ahead is longer than anyone can truly grasp. Their next destinations are not planets, not moons, but stars. Stars so far away that they are mere points of light in our sky. In about 40,000 years, Voyager 1 will pass near a small star called GJ445 in the constellation Camelopardalis. It will come within 1.6 light-years, not close enough for a visit, but close enough for a flyby, a silent passing. Voyager 2 will follow, 20,000 years later, brushing past Ross 248. These meetings won't be observed. They won't be recorded. But they will happen. And then, the spacecraft will keep going. They will continue on their journey for millions, perhaps billions, of years, drifting between the stars, untouched by time, radiation, gravity, or decay. Out there, in the dark, nothing moves fast, nothing erodes. Their metal will remain long after Earth has changed, long after humanity has faded, long after our monuments have crumbled and our satellites have burned in the atmosphere. Even after we are forgotten, the Voyagers will remember us. They will be, quite possibly, the last traces of human existence in the physical universe. Not statues, not ruins. But these twin messengers, whispering into the dark, telling the cosmos, we once existed. We once wondered. We once dared. There is a kind of poetry in that. Voyager didn't set out to make us immortal. But in its quiet journey, it may have done just that. It may be the one thread of humanity that survives the rise and fall of civilizations, the death of languages, the turning of stars. Out there in the black, beyond the heliosphere, beyond even memory, they float, alone, intact, and eternal. But they won't speak forever. The power that drives them fades more each year. Sometime in the late 2020s or early 3030s, they will fall silent. One by one, the instruments will go dark. The tiny thrusters will no longer fire. The antennae will drift, just a few degrees off, and the signal will vanish. And that will be the end. Or maybe it won't. Because even in silence, they will endure.